Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In the second lecture of CASTEP, I want to proceed our discussions for setting CASTEP calculation. In our first video, we discussed about first step. In this video, I want to proceed our discussion about more. So when we click on more option, we get this type of interface in which we have different things: minimizer, option, and stress. In minimizer, we have convergence tolerance, quality, energy, maximum force, maximum stress, maximum displacement. Quality is about to automatically set these parameters. We have different options: quality, coarse, medium, fine, and ultra fine. Coarse is just for if you want to test your file, and medium for standard calculations, fine and ultra fine for get more precision and accuracy in the calculations. So the second step is about energy, electron volt per atoms. It is basically the minimum change in the total energy per atom required between optimized steps for convergence, and this energy ensures optimized steps when the energy is stable. The typical value of this energy is 1 multiplied by 10 raised to power minus 5 electron volt per atom. You can type this value, you can lose this value. If you want to get accuracy in calculation, you must be type this value. And the second thing, we have maximum force. This is basically the threshold for the largest force on any atom at convergence. And through this maximum force, we ensure all the atoms are nearly force free in the optimized structures. And we have the another thing is maximum stress. This is basically the limit for stress on the unit cell after optimization, and this is important for variable cell calculation to ensure correct equilibrium shape. So the typical value of stress is 0.02 gigapascal. It's good for calculating elastic property, or you want to get accurate lattice constants. So you must be apply maximum stress. You must be apply touch value of the maximum stress. And another thing, we have maximum displacement. This is basically that are just allow atomic movement between optimized step and the convergence. This maximum force prevent atom from jumping. And we have another thing with the maximum iterations. This is basically the upper limit on iterations, or we can define this is the limit for the number of optimized steps. This maximum iteration prevent endless loop if convergence cannot be reached. So you can increase or decrease from here. So the typical value is from 100 to 200. You can increase this value for if your convergence, or you may say that if your system converges slowly, you can increase this maximum value of iterations. And the another thing is cell optimization, in which we have different options: non-full, fixed volume, fixed shape. This determines whether the unit cell parameters are optimized along with atomic position. And by changing the value of cell optimization, we get these two further options in CASTEP geometry optimization: base set for variable cell and compressibility. This base set for variable cell control how the plane wave's basis set is updated during variable cell optimization. And we can define compressibility as the parameters that guides CASTEP in variable cell optimization by controlling how easily the latest vector are adjusted. So we have three options: soft, medium, and hard. This compressibility helps convergence when after minimizer, we have another tab with options. Whenever you click on option, you get this type of interface in which we set about logarithm for our calculations. In logarithm, we have different options: LBFGS, BEFGS, DEMT, MD, and TPSD. These are all different logarithm for calculations, in which we have different checkbox. Whenever we click on LBGF, we select LBGF. We have checkbox with using use line search. This is basically ensure each step reduce energy safely. Through this, we can improve stability of calculation. And if you select BFGS, we have another checkbox with using delocalized internals. This delocalized internal use bond lengths angles instead of Cartesian coordinates, oftenly improving convergence if we have molecular systems. This checkbox is basically about for these two logarithms, LBFGS, BFGS, and if you are interested to move forward for damped molecular dynamics, whenever you click on damped molecular dynamics, this damped molecular dynamics is basically for minimizing scheme where atoms are moved according to force but damped to remove kinetic energy and gradually reaching equilibrium. This logarithm is more good than LBGF or BGF for difficult cases, like if you have flat energy surfaces, if you have highly unstable starting structures, if you have instability in your structure, you can use damped molecular dynamics, in which we have different options. The first thing is a damping logarithm. In damping logarithm we have different options like independent, coupled, and TPS descent. This independent is basically select each atom damping separately. If you select coupled, this means atom damp collectively. If you select GPS descent, this is more simplest gradient, which is good for damped molecular dynamics. And if you select independent, you have another step with a damping coefficient recalculation frequency, and this is basically to control how compound damping is adjusted. If you give large value to these options, your calculation will be smoother but take very long time. After that we have wave function explorations. We can define wave function electron wave functions between steps to speed up self-tolerance force of convergence, in which we have different options. First, second, third, and the more stable is none. And another thing is a time step. Basically, this is the size of the molecular dynamics integration step. If you take smaller value of this time step, this will take longer time but very safe. Your calculation will be very safe. If you take larger value of time step, it will be faster, but maybe your structure, your optimization, your calculation will be unstable. And we have a checkbox with auto update time step. Through this you can automatically set that the CASTEP allowed to adjust time step to balance stability and speed. So this is all about the logarithm of the calculations. After that we have another tip with stress, in which we can apply stress on our structure. So this stress step allow you to apply external stress on your system in a unit of gigapascal. So here we have option with external stress. You can add xx value, xy values, and x, y, and z value manually, and you can add hydrostatic pressure. Just give one value to the system. CASTEP automatically converts sigma xx value, sigma yy value, and sigma zz value according to stress tensor. So here we have a tab with reset. From this reset you can zero your external stress. If you give some value to this, for example, if you apply some stress value of x and y's, when you apply on it, through this you can reset your stress. Okay, so through this you can adjust your parameters and setup tab. After that we will discuss about electronics, properties, and controls one by one, briefly, every step in detail. So be with me. Thank you for watching and subscribe my channel.